With those announcements said, I think we can hand it over to Saad. And at the end, I believe there might be some evaluation feedback that we have for you guys as well, and we'll follow up with more details on that. Thank you. Take it away, Saad.
Thank you, Sean, for the introduction, and thank you all for those of you attending this presentation. So this is the second session of the N3C orientation, as mentioned by Sean. And the scope and the target audience are basically, so it's recommended that you've attended session A a week ago, but if you didn't, don't worry, we'll review some of the stuff that was covered last week. The audience is mainly for people who just registered to N3C and have an account created, or people who want a refresher, or people who are still trying to figure out how to navigate the enclave. And lastly, this is going to be a practical session. So we're going to cover some of the tools for data analysis within the enclave. And this is not going to be an in-depth overview. We'll provide additional resources and more in-depth documentation. But this is hopefully should help you get started and navigate better the enclave. This is a tentative outline for today. So we're going to start with a refresher from session A, talking about navigation, projects and folders, the data catalog, how to look for data, and some of the analysis tools. And then we're going to focus more specifically on concept set tools and data analysis tools within the enclave. And then we're going to move on to more code-based tools. So Code Workbook is one of the code-based tools. And lastly, we're going to mention some of the available apps that help you explore the data within the enclave. So let me move to the enclave homepage. And this is basically what you see when you connect to the enclave. This is the homepage. You see a bunch of statistics about the available patients and how many of them are COVID positive or COVID positive patients. There is a data tab which explains, gives the links of the main data used within the enclave, but also explains the process on how to request access to existing data, whether it's for a new project or to join an existing one as a collaborator. There is a training tab which has a bunch of resources to get up to speed. So the training portal is a bunch of training specific to N3C and the enclave. And then we have additional documentation. Academy and documentation are helpers and tutorials that give you more information about the tools within the enclave, how to work with the product, basically. So Academy is more short tutorials and documentation is more in depth. We also have a link for Troubleshooting Center, where when you have issues dealing with the tools and data, and a support and contact section, which basically gives you a link to file a support ticket, whether inside or outside the enclave, and we're explaining the process a little bit in here, with a link also to some frequently asked questions. So I'll come back to this in a bit, but this is more for an orientation purposes. On the left panel here, you have some of the links to the existing tools and the existing locations that you will use within the enclave. So the homepage basically takes you to the homepage that we've discussed. Project and files is basically where all your files or folders will be saved. So if I click on it, you will see here a bunch of research projects that are within the enclave. Obviously, you'll be able to access the ones that you've been permissioned to. And you can filter by project here and start typing in the project name to search for the project you're looking for. So that is the list of the existing projects. There is also the data catalog, which is essentially a collection of files, apps, and resources that are the most used within the enclave and that are shared. So I'll come back to it in a bit, but you can notice here there is an LDS data folder, which is the collection of domain tables if you have LDS access, and an equivalent de-identified data folder, which has the domain tables if you have de-identified access instead of LDS. And we're going to be looking at the SynPath synthetic data folder, which is a public domain tables that are similar in schema to LDS and de-identified data. So for the purposes of this demo, we're going to be using this folder. And then you have here some dashboards and apps is a collection of useful apps that we'll explore in this presentation, and a collection of user guides also that we'll refer you to as we go through this presentation. So that's a way to navigate the existing folders and data sets. There's also another way. Using the search bar in here, you can search for a resource or a data set of interest. So for example, I can, if I don't know the location of a drug exposure table, I can just start typing in the name of my table in here, and it will pull up the results corresponding to my search. And I can click on the table and open it and explore it. So that's for navigation. This apps section shows you all the available tools within the Enclave. Today, we're going to be focusing more on Contour and Code Workbook, which are data analysis tool. And we'll mention a little bit Fusion, which is sort of a spreadsheet tool within the Enclave. But there are a lot more tools if you get more advanced, and you can view them all in here. And lastly, here you can see this is all the resources, data sets, or folders that you put as favorites. So for quick access, you can access them in there. So for example, if I'm on my projects files, and let's say I have access to this research project, I can make it as favorite, and it will show up in my bar in here, and I can access it from here. So as you can see, it's in here, and I can open it from here. And then last but not least, you have the help and support button in here gives you access to some resources if you need help. Some of them are academy and documentation, which I talked about when showing the homepage. And another one is if you want to report an issue, which is basically creating a support ticket within the Enclave. And the support ticket could be either to report a bug, a build error, or if you have a question about a tool or a specific data, you can click on it here and say, for example, I need development help, and provide the title and description and report on a specific resource that you're working on. And this will help us get back to you and investigate your question or your issue. So let me close this window. So that's for quick navigation. Let's now go back to the data catalog and open the SynPath synthetic data. And as you can see here, there are a number of domain tables, measurement table, observation, etc. And so we can choose to open one of the tables to explore it. So let me, for example, open the procedure occurrence table, which is a domain table that has records about procedures. And when I open the data set, I use data set and table terms interchangeably, but essentially it's rows and columns within the Enclave. And you can see you can preview the data in here. On the left side panel in here, you have some metadata about the table that you're looking at. So for example, you can see that this procedure occurrence data set was updated on October 1st by this person, Sean, and it was created. You can see who created the data set. This is the location, the path of the data set within the Enclave. And you have some statistics. So this one is 19 columns and 3.9 million rows. And what's useful for provenance is you can see the inputs that were used to create this data set, and you can click on them and navigate on them, and the logic that was used to create this data set. So this SF SIMPOF schema line. So the logic could be, as we'll see soon, it could be code, it could be a contour analysis, or different types of logic that would create this data set, but you can see the provenance on this left panel. You can also, if you're not familiar with the data set, navigate, click on the columns section and navigate all the columns that exists in this data set with a bunch of statistics on them. So that's one way to navigate the column. The other one is to search for a specific column in here. So for example, if I start typing something like name, it will filter down to columns that have name in the string that represents the column name. So you can see procedure, concept name, and other types of columns. And another useful tip for navigation and exploring the data is that if I click on the column in here, it will load on the bottom here some statistics about the column that I clicked on. So we'll just wait a few seconds for it to load. While it's loading, I can also point to some useful navigation, or it actually loaded, so you can actually look at the some statistics about this column. So this is, if it's a string column, depending on the type of column, it will pull up different statistics. So you can see, for example, 14,000 rows have length 11. I can maybe look at just this one long-term drug therapy, which has 200,000 rows. And if I click on it and I click keep it, it will apply this filter, and we'll only be looking at data that corresponds, for which the column value corresponds to this long-term drug therapy. So that's one way to explore the existing data, and we'll show other ones in a bit. So now that we've seen, so this is the path of the data set where it's saved. I can go back to my folder, the SIMPOF folder that I've opened. And now that we've seen some of the domain tables and where they live, so some of them are conditions, measurements, the question is, how do we filter these domain tables, whether it's a condition table, measurements, procedures, or medications, to define the relevant electronic health records or cohort to study? And this is where concept sets can be useful. And what a concept set is basically it's a collection, a set or a collection of concept IDs or codes from the OMOP vocabulary. And these are used to define phenotypes. So examples of that could be a set of condition codes that are used to define chronic kidney disease, or a set of codes that correspond to lab tests for white blood cell count, or maybe just a set of condition codes that helps me define COVID positive patients, for example. So in order to explore we have a number of tools that helps you deal with concept sets. And the first one of them that I wanted to show is called the Concept Set Browser. And if you go to the home page and go to the Discover tab, this is one of the tools available. And the Concept Set Browser is basically a tool that lets you explore existing concept sets that has already been defined within the enclave by other researchers. And you can maybe use some of them in your analysis to define your cohort or health records. So you can see here all the existing ones. And on the left panel here, you can either search by keyword or search by status of the concept set, or by the person who created the concept set, or the person assigned to review it. So let me just pick an example and type the keyword PCR. If I'm interested in a concept set that defines PCR tests. So this one looks interesting, Atlas SARS-CoV-2 PCR and AG. And this one is basically, if we open it, this one corresponds to lab measurements that are either PCR tests or antibody tests. So it's very useful to define COVID positive patients. And if I open it, I see that there are two versions of this concept set created by these two people. Let's pick the latest version. And when I open it, I can see that this concept set, or we also call it code set, is uniquely defined by this code set ID in here. And this is the name of it. And we can see when it was created and who created the concept set. And if we scroll down, we can see some information such as, what we see here is that this concept set was used in these three research projects. So cohort characterization, orthopedic surgery, for example. And we can see that it's been used to define three different cohorts that we can explore by clicking on these links. But more importantly, we see that this concept set has 55 codes or 55 concepts, and we can explore them from this tab when we click OMOP concepts. This is the list of all the concepts that are within this concept set. We see that most of them come from the LOINC vocabulary. Some of them are SNOMED vocabulary. And we can click randomly at one of these concepts to have to get more information. So this one, for example, is a lab test, and it is a measurement. And this is the code defining it, the concept ID defining it. So you can get some information about it. And this is the name of the concept. So now that we've seen how to explore existing concept sets from this concept sets browser, the question is, how do we use this in practice? How do we use this in conjunction with my domain tables to filter down to the records I need? And for that, let's go to the data set that is back in this view. And that one is also on the data catalog. So most of the data sets that you need are in the data catalog. So if I go to data catalog and click on OMOP code sets, this table concept set member is very useful. So let's open it. So this table is basically a mapping between the concept sets that are defined within the enclave, and they are uniquely identified by their code set ID. But you can also see their name here. And each concept set is mapped to the list of concepts defined by either concept name or concept ID. So each code set has a number of concept sets that it contains. A number of concepts, sorry, that it contains. So uniquely identified by their ID or by their name. So one thing we can do here is we can click on Analyze this data set. And this will take us to this tool that I mentioned at the beginning called Contour, which you can also access to from this tab. So there are many ways to get into the same view. But this is essentially a point and click tool that helps you analyze data or produce visuals or produce reports. And it's non-code based. So you don't need to write code in order to use this tool. And so what you see here is, this is our input concept set members, and it has 1.9 million rows. And this is the starting point of our analysis. And these are a number of boards or transformations that you can apply to analyze your data. So some of them are visualizations, Some of them are more like transformations to transform data, add new columns, compute some measures, and some helpers to edit columns, etc. So one thing we can do is in Visualize, we can start by applying a table board, which is basically just a preview of your data in terms of rows and columns. Now, so this is a preview of the data set, concept set members. What we can do also is apply a histogram board. And let's say I'm interested in exploring all the concepts within this concept set member table. So maybe let me pick concept set name as a column to display. And we're just going to look at the counts of concept names within this data set. So as you can see, these are the name of all the concepts within concept set member table. And each one has, this one, for example, has 1,600 occurrences. We can also, interestingly, we can look at code set ID. So this would give us the distribution of each concept set, meaning how many concepts are within each concept set. So this might be a more relevant histogram to look at. So as you can see, this concept set 4.5 that starts with 456 has 47,000 concepts within it. So there are big concepts, large concept sets, and there are also other ones which have, for example, this one has only 55 concepts within it. So let's say I want to filter to a concept set of interest, and I can apply a filter board for that. And let's say I'm interested in concepts that contain the name pneumonia in them. So I'm going to pick the column concept set name, and I'm going to keep the ones that contains the string pneumonia. And if I click save, and now if I do something like a summary board, which is basically just computing the number of rows of my resulting data set after applying this transformation. And while it's loading, we can also look at the lists with a histogram, the list of concepts that has the name pneumonia. So again, we're going to pick concept name. So as you can see, 16,000 concepts contain the string pneumonia, and you can look at them into here. While matching with doing a filter board and matching on the string to find your concepts might not be the best practice, because you might be missing some of the concepts or including other ones that you don't want. And so the best practice generally is to filter using the concept set ID. And so for that, let's go back to our concept set browser that we were looking at earlier. And let's look for the keyword pneumonia. And just for example, I'm going to pick this one, this concept set, non-influenza pneumonia, that has been defined for training purposes. So this one has only one version, and it was created by Sean. And if we open it, we can grab the code set ID from here and use it in my contour analysis. So, which is usually a more efficient way to, a more accurate way to filter to the concepts of interest. So instead of concept name, I'm gonna pick code set ID, and code set ID, I want it to be equal to this number that I grabbed from my concept set browser. So if I click on save, and as you can see here, as expected, if you look at the this concept, non-influenza pneumonia, it has 221 concepts within it. So when we filtered on this concept ID in our contour analysis, we have 221 rows corresponding to the concepts within this concept set, non-influenza pneumonia. So before now, what we want to do, since we have the list of concepts of interest, we may want to join with the specific domain table to get the corresponding health records. In this case, because these concepts are conditioned, we would like to join. We're going to join with the condition occurrence table, which is the domain table that has condition records. So there is a board called join in here, which we can click on. And we are going to grab the condition occurrence table from the data catalog. So if I go back to data catalog and pick the SimPAP synthetic data, I can pick my condition occurrence table. And if I open real quick this condition occurrence table on a separate tab, and as you can see here, each condition is defined by this condition concept ID. So this is the column that we want to match with our concept ID that we grabbed from the concept set member table. So going back to my contour analysis, I'm going to add all the columns from this condition occurrence table, and my matching condition is going to be on the concept ID. So the left table has the concept ID column, and we wanted to match the condition concept ID column from the condition occurrence table. And because what we want is basically an inner join or an intersection, we only want the condition records that are strictly matching the concept IDs of this table we just defined. We're going to pick intersection as the option here to join. And so if we click on save, and if we click on calculate summary, just to check the number of rows, the number of resulting rows, from picking only the pneumonia conditions from this condition occurrence table. Let's wait for it to calculate. And as you can see, now from the condition occurrence table, which initially has 14.8 million rows, my inner join to keep only the concept IDs of interest gives me a table of 31,000 records. So as an intermediate step, if this is a table that, and if we click on the table board, we can visualize the results. But let's say this is the output of my analysis, and I want to save it as a table to be reused by other people or in a different analysis than this one. I can save the resulting data, the resulting table as a data set within here. And before saving that, let me actually save the analysis, and let's call it N3C orientation pneumonia example. Sorry. So the analysis is saved in, and we're going to do save as. And in my case, I'm going to save it in, I have an N3C orientation folder that I've created for the purposes of this presentation. But from In your case, that would probably be the research project that you are working on, and you would be able to save your data sets and resources in there. So let me save my analysis in here in this N3C orientation folder. And after saving it, you can see that it's under N3C orientation folder. And if I open it, I can see my resource, which is in this case, a contour analysis saved within this folder, so I can come back to it later. But now that I've saved my analysis, let me also save the results of this path as a data set. And let's also save it in our N3C orientation folder. And let me call it pneumonia conditions example. And so it will take a few seconds, maybe a couple of minutes to build, depending on the size of your data set. But then you'll be able to access it just like any other data set within the enclave. And in my case, I saved it in this N3C orientation. So you will be able to find it in here. Now I will go a little faster on this analysis just to show additional functionality that this tool Contour can provide. And so we can move on to other tools within the enclave. So one thing I can do, if you notice here, I have some columns which are dates, a condition start date, and a condition end date. So I may be interested in defining a new column, which is the duration of my condition, and which would be the difference between these two dates. So for that, there is what we call an expression board, which lets you write some code similar to SQL to either create new columns or update existing columns. So in my case, I'm going to create a new column and call it condition duration. And there's a function already existing, which is called datediff. You can look at the documentation by clicking on this I button in here, and it says it basically returns the date difference in terms of number of days. So I'm going to do a difference between my condition start and end dates. And I'm going to apply my transformation, and let us visualize the results with a table board. And as you can see, we've created a new column in here, which is an integer called condition duration. And that was created by this expression board. And obviously, so the transformation in this contour analysis are linear. So since I added a new expression board, my output here, pneumonia example, is going to update to include this new column. One nice feature here is you can, for example, if you have a histogram, you can click on a specific bar, and it will automatically apply a filter and update the results of your subsequent boards here. So we're not going to wait for it to load, but I just wanted to mention this functionality that is useful for iteration. So let me click here to remove this filter that I applied. Now, let's say, so I've applied I applied this expression board. I have a saved data set. Let's say I want to create a report of my results. And that's a report that can have multiple outputs or graphs, and that I want to share with my colleagues for further collaboration or for review. So for that, let me create a visualization. And I'm going to pick this grid board. And let's say I want to look at the unique count of persons. And I want to show it as a function of the concept name, so as a function of the condition and as a function of the condition duration. So let me pick in the x-axis condition concept name, which is basically your condition, and the duration in the y-axis. And so what I want to show is a count of the patients. So unique count of person ID. And let's hit compute and look at the results. So as you can see here, this is a grid, or you can call it a heat map as well. And it's showing the count of patients as a function of your condition duration and as a function of your condition. And if I want to put this result in a report for people to review, I can click on add to report here, and let me create a new report. And let's name it N3C orientation report example. And I'm going to save it in my N3C orientation folder as well. So let's save it in here. And you can see here we have a quick link of the reports, but it's also saved in my N3C orientation folder. But if I open it, you can see the results, the graph that I added to the report. I can format it a little bit, maybe make it bigger. I can add some text here, so like an introduction, and format that. And this is basically, this will be a report in which I can add both graphs, text, and tables for other people to review. So last thing I want to do is another example. Let's say I'm interested in looking into demographics and bring in the gender to this list of patients that I have in here. What I can do is create and the demographics are in the person table, which is a domain table, also in the data catalog. So what I can do is create a new path in here. And you can think of paths as separate tabs, just like you have separate tabs in an Excel spreadsheet. So I'm going to create a new tab, and I am going to grab the person table, which is also in the data catalog. So again, in SimPath synthetic data collection and person table. And so maybe let me add another chart in here to give me an idea of the demographics and more specifically the gender. Well, before doing that, since I grabbed the person table in here, what I want to do is in the resulting data set that I have here, I want to add the gender from this person table. So for that, I can do another join transformation. And instead of grabbing a data set within the enclave, I'm going to grab the result of my person path. And let's say I'm just interested in my gender, in adding the gender as a column to my existing data set. And in this case, the match is going to be on the person. So person ID is the matching condition. And I'm going to keep add columns. So we're only interested in adding attributes to our existing table, not an intersection. So let's hit save and look at the results. And so now that I have the gender, it will load in a bit. I can also create a chart to visualize. So let's see here. the gender column has been added to my existing data sets. So let's say I want to look at again, the distribution of patients, but broken down by gender. So I'm gonna pick the condition name in y-axis, and I'm gonna show the unique count of person IDs, but we're gonna segment it by gender. And let's hit compute and save. And so let me actually show it as grouped bars. So as you can see here, a breakdown of the count of patients by condition and also broken down by gender. Let me add this graph to my existing reports. So if I click on add reports, this is the report that I created, N3C orientation example. And if I go back to it, you can see that this is a graph that has been added. I can also format it, give it a name, and switch to view mode. And this is basically my report. And one thing to note is that this report is interactive, meaning that if and when the underlying data updates, the results in this report will also update. There is also a possibility to add parameters in this report to have your results change depending on the parameters you pick. We're not going to cover that today, but we will point you into the resources that you need to make this report more useful. Yeah, so that's on Contour and reports. Before I close on the concept set tools, I wanted to show some additional concept set tools that we have within the Enclave. Quicker, but it's worth mentioning. So let's go back to the data catalog again. And in dashboards and apps, and what I wanted to show is in case the concept set you're looking for is not within the concept set browser, you're looking to define a new concept set, or you want to start with an existing concept set within the browser, but refine it by adding or removing new concepts. We've developed a tool for that, and that tool is called the Concept Set Editor. And I'm going to show briefly how it works without covering all the functionality, and I'll point to the documentation for all the functionality. So I can search for an existing concept set, the concept name here. So the one we just picked, which is non-influenza pneumonia, or maybe let me grab it from in here so it's easier to find. So I can search for an existing concept name within the Enclave, and in this case, this concept name that I can load in my editor. And when I load it, I have information about the existing concepts in here. The concept expression is also another way to look at the existing concept IDs. So this one is like a master concept set, and it includes all its descendants. But this is basically a tool that lets you refine concept sets within the Enclave. So for example, if I want to remove this existing concept ID from my concept set, I can click on it and remove selected. And now I'm left with only this concept ID, which corresponds to all these concepts in here. So that's one way to refine it. I can also add existing concepts using this window in here. So if I search randomly for pneumonia, and I randomly pick this one, rheumatic pneumonia, I can add it to my expression, and you can see it in here. So if, for example, this is my refined concept set, I can basically update this one, so create a new version, or create a completely new concept set using this tool in here. And the last thing I wanted to mention about this concept set editor is the Atlas JSON. So for those of you who are familiar with Atlas and have an existing concept set that you want to import from Atlas, which is an external tool that is not within the enclave, you know that concept sets are defined by a JSON string, and you can grab it from Atlas and pass it in here. And if you pass it in here, it will automatically create it within the enclave. So that's in the concept set editor. The last thing I wanted to mention about concept sets is the documentation. So it's available from the browser, the concept set browser. If you click on it, you have a more in-depth tutorial that lets you, that gives you information about the existing tools to manipulate concept sets. So a general background, how to upload an existing or concept set or create a new one, either from the enclave or using Atlas, how to update existing concept sets within the enclave, as well as how to use it in an analysis. So part of what we covered today. And then the SOP for reviewing concept sets within the enclave so that we have some good quality ones that researchers can use. So that's all on the concept set tools. The next app or tool that I wanted to mention is the Code Workbook, which is a code-based tool. And I wanted to show it in the context of doing the same transformation, the same analysis that I did in this contour analysis. I want to redo the same one in a Code Workbook. So some of you may prefer writing code, either R, SQL, or Python, for example, and this tool lets you do that and maybe do some more advanced data analysis or even more advanced modeling. So I'm going to go to my N3C orientation folder and create a Code Workbook in there. So if I click on this green button, new, and create a Code Workbook, you can also create it from here by clicking on this icon, Code Workbook. And so for people who prefer writing code, you can think of this environment as either Jupyter Notebook for people who did Python, or RStudio for people who use R more frequently. So it's an environment and an editor for code within the enclave. So it lets you interact with the data that exists in the enclave and save resources in there. The first step I'm going to do is import the data sets that I want to play with. So the ones we've used in our contour analysis are concept set member and the condition occurrence table. So let me grab the concept set member from OMOP concepts. And when I load it in here, you can see that it's basically part of a graph, and you can see the preview of it, and we can start applying transformations. But let me first load my condition occurrence table as well. So that will be in the SimPath synthetic data and condition occurrence. So now that I've loaded these two tables in my workbook, I can start writing code and playing with them. And there are a couple of ways to start writing code. The first one, the main one, is basically create a transformation. And a transformation is basically a function that takes data sets as input and returns a new data frame. But before that, I wanted to show the console. And the console is basically just lets you play with some function calls, maybe check your syntax, explore the data in a bit. So you have R, Python, and SQL codes available. So for example, let me do something in R where I want to visualize the first few rows of my concept set members table. So each table is referred to, so condition occurrence is and concept set member. This is the variable that I can use in my code to refer to the table. And so I want to maybe do something like head concept set members and show the first 5 rows, I can do it from this console. And while it's running, let me give a name to this code workbook. So my N3C orientation workbook example. And as you can see here, we've shown a preview of the data set. We can do the same thing in Python. So maybe let's look at the count of rows of my concept set member table. So we can also do it in Python code, something like concept set members.count, and it will give me the number of rows of this concept set member data set. But now let's start doing the analysis that we did in Contour. And so for that, I'm going to create a new transform. So either from this blue button here or here from the data set. So if you do it from the data set, it will let you pick the code, the language of your choice. And let me start with R as an example, but you can also use Python or SQL. And I'm going to talk about templates in a bit. So when you create a transform is basically a function either in R or Python. And it takes as an input your table, which is considered the data frame. And it has to return another data frame, which you'll be able to preview in here. So let me add the other input, which is my concept set member table. And so in order to add it, what I can do is either click on the plus button in here and click on my input, and it will automatically take the concept set member as an input. Or I can simply just write it down, concept set members, and it will automatically recognize it. So now my transformation, let me close this console and maybe expand my code. So my transformation is taking these two data frames, and I can write my code in here to return a new data frame. So something to note here about the languages is that you can you can use Spark or you can use native R for manipulating data frames. You can use, if you use R, you can use native R to manipulate data frames. If you use Python, you can use a library like Pandas to manipulate data frame. But you can also use Spark, which is basically an open source analytics engine or framework for large scale data processing. So Spark basically uses parallel computing and distributed storage. And so if you write code in Python or R, you can use some libraries like PySpark or for Python or Spark R for R to leverage Spark capabilities. So again, you can use your native R libraries and your pandas in Python, but Spark gives you a lot of advantages in terms of like computation efficiency and speed and storage. So when the data set starts becoming big, it's probably worth learning the syntax for these Python and R libraries. So in my case, I'm going to show you an example where I'm starting with still an R code, but I'm specifying that these data frames are going to be interpreted using Spark syntax, so Spark R, instead of native R. But you can also switch back to native R if you want to. And just to go faster, I already have this code saved for this presentation. So to avoid retyping it, I'm gonna just pass it and explain what it does. So first of all, let me give a name to my output. So in that case, I want to select my pneumonia condition. So call it something like selected pneumonia. But let me pass my code in here. And basically what this code does, the output is called selected pneumonia. It's going to be a data frame, and it's taking these two tables. And I'm starting with my code set ID, the non-influenza pneumonia that I showed when doing the contour example. And this is basically just filtering, just like I did in contour, filtering the concept set member table to this code set ID. And after filtering, I'm performing this join. So I'm joining my input concepts. So this is just to keep the concepts that I want. And then I want to join them with the condition domain table to keep only the conditions corresponding to my the concept that I selected. So this is an inner join that basically lets you join the condition occurrence table with my selected concepts. So if I want to run this, let me save the results as a data set in Foundry in the enclave. So the data set is also going to be called selected pneumonia. And now I can run this code. And depending on the size of your data, it might take a few seconds, a few minutes to run the transformation and produce, in my case, my pneumonia condition records. So while it's doing that, I may want to show, as you can see in this code, I'm kind of hard coding my code set ID in here, which is not always an elegant way to do it, especially if I start having to maintain multiple concept IDs, multiple concept sets, and I want to iterate and change them. And so basically, if I want to have a configuration file on which I want to change these code set IDs and have it run in here, I can use a spreadsheet called the Fusion spreadsheet. And this will be basically my configuration file. So let me open a spreadsheet and save it in my N3C orientation folder. And I will explain what I mean by the configuration. So let me call this my concept set inputs. And I'm going to save it in N3C orientation folder. And what I want to do essentially is maintain a list of code set ID in here. So let's call it code set ID. So the name and the ID. And just for example, I'm going to have two examples here. So pneumonia, which is the one we used, but let's add another one, another code set ID corresponding to cancer condition to this spreadsheet. In order to be able to use this spreadsheet from a contour analysis or from my workbook, I need to save it as a data set. And for that, if I click on data and then sync on table, let me call the table my input concept sets. And sorry, I'll have to select my data and then give it a name. So I'm going to click on add new table. And what this is doing is it's going to create a corresponding data set, a data set corresponding to this spreadsheet. And it might take a few seconds to build. But what I can do is import this data set from my code workbook. So let me go back to my workbook and do an import data set. And it is saved in my N3C orientation, and this is the input concepts. So it'll just take a few seconds to sync. So let's give it that time. And while it's doing that, so as you can see here, the R code finished running, and you can look at preview of the results in here. You can open the data set on a different tab and explore the results. And then this is a data set that you can also analyze from a different contour analysis or from your existing workbook. So you can click on analyze here. You can analyze it from a code workbook. If you have a code that produces visualizations, you'll be able to see them from this tab. The inputs tab is basically the inputs of your transformation. So in this case, I have 2 tables, and you can look at them from the inputs tab and toggle between them and visualize them from here. So let's see if our input concept sets finished running. As you can see, this is what we wrote in our spreadsheet, and now we can use it from our code workbook. So what I may want to do here is let me refresh the page so I have the data. So as you can see, this is my input concept sets data sets that I've defined in here. So now let me add a transformation leveraging on this configuration file and doing something similar to what I did here, which is basically finding the pneumonia conditions, the pneumonia condition records. So I'm gonna add a new transformation, and just to change and mix it up, let's pick Python in this case. And I've already have the code written down. So just to save some time, I'm going to pass it in here and then explain it. So what I'm doing in here is, let me first make sure my inputs are correct. And so I'm selecting these inputs concept sets in here, and I'm basically doing an inner join with my concept sets member tables to only keep the concepts that are either pneumonia or cancer. So this is the syntax for a join in Python. This is using the library PySpark, but you can also use pandas. And then, similar to what I did with my R code, I'm doing an inner join between my selected conditions and the condition occurrence table to only keep my selected conditions. So again, let's save it as a data set, and let's call it maybe selected conditions Python example. And let's run it. So while it's running, like I mentioned, this is leveraging on Spark library. There's a cheat sheet if you want to, and that's available in the documentation for if you're interested in learning Spark syntax, just to gain in terms of like efficiency in code iteration. And let me show where it is. So most of the training and documentation are in this training tab. And if I go to docs, which is a more in-depth documentation about the existing tools, there's one that there's a section about code workbook. And in PySpark reference, there's a PySpark syntax cheat sheet. So you can refer to it if you want to get familiar with the syntax, and you have examples of filtering, joining, and some other common operations for data analysis. So the last thing I want to do while this is running is, well, first, just to finish on this, you can write obviously Python and R code. You can import libraries that you want to use. So for example, in R code, this is the way to import some of the libraries like dplyr if you want to use it within your code. So this is, you just import it within your code editor, and then you can refer to it within your code. Similarly, in Python, you can just import it from here. So there's a useful PySpark library called pyspark.sql that I can import by doing this. So I'm going to import a library called functions from pyspark.sql, and I'm going to rename it F. And so I can refer to the functions from this code editor. Now, if I don't want to rewrite all these imports for each transformation that I have in this workbook if the workbook gets complex. There is a global code in here that you can use. So if I, instead of having my imports in this specific transformation, I can put it in the global code. And what this does is it's gonna execute this import or whatever code I have here in all the transformations that I have within this workbook. And you can do the same thing for R. So instead of having the import in here, you can put it in the R global code so that it's available for all the transformations. As you can see, the Python code just finished. You can look at a preview here of the results, and you can iterate on your analysis here. So the last thing I wanted to mention about code workbook is what we call templates. When you start writing code that is that can be repeatable and you don't want to reinvent the wheel or copy paste it every time, or you want to share a code with colleagues so that, or share functions with your colleagues so that they don't have to rewrite the same code every time, you can use what we call templates or code workbook templates. And let me show you how to do that. Let's say here in this function, I want to create a template that basically would take any code set ID as an input and run this code. So without me having to retype the same code, what I can do here is create a template from this action section. And creating a template, you can give it a title. So let's call it, for example, filter to specific concept set and get corresponding conditions. And you can see that it's taken as parameters the concept set member table and the condition occurrence table. And let's add the parameter, which is the code set ID. So the way to add it, let's give it a name first. So input code set ID. And if I just highlight the instance of it in here, it will automatically replace it by a variable. And so I can specify things like here, the variable type is a number, and we can give it a default value. So like the pneumonia example, we can give a description in here, but basically this is the way to create a template. And I'm going to create this template and save it also in the orientation. So let's call it template and save it in the orientation folder. So now that I've saved it, I can, as you can see here, instead of a code, you see an interface in which you can specify your inputs. If I don't want to, in this template, I see that concept set members and condition are also inputs that you can change. If I want to make them fixed and not change them and allow the user to just change this parameter, the input code set ID, I can edit the template further and go to concept set member table and make it a default. And same thing for condition occurrence. And let me update the template again. And if I click on it, sorry, that was the one. So I may, now that I have my existing template, other users, researchers can refer to it and use it from other code workbooks. So let me show an example of that quickly. So let me create another workbook. And call it something like using defined template. If I in a new transformation, instead of picking R, Python, or SQL, I'm gonna look for the templates in here. And I think the name of it was filter to, if I'm not mistaken, filter template, filter to specific concept set. So I can look for it in here. and pick this template. You can look at the details in here and what it requires, and then apply transformation. And it's going to automatically load my, well, I didn't do it properly in here, but it should automatically load my concept set member and the condition occurrence table. And you can run it from your other workbook. So let me fix so yeah, that's about creating and reusing templates, code workbook templates. So that's on code workbook. Now for pieces of logic that we want to make available to other researchers within the Enclave community, we have what we call the knowledge store. So that was the next tool that I wanted to show. If I go back to the homepage and on the Discover section, let's open the knowledge store. And the knowledge store is basically an app that has shared logic defined by different research teams within the Enclave. So you can create a code workbook template, and if it's something that you think can be used by the N3C community, you can push it to the knowledge store, and that will help other users shop around and look at existing logic in the knowledge store and reuse it if this is something that they think can be useful within their research, so that we avoid reinventing the wheel. So all the knowledge objects are in this left panel, so you can click on them, and this is, for example, a template that works on LDS data. And this is a description of it. And this is where the originating project, so where the research project that created this template. So this is a nice tool for collaboration and reusing logic that is shareable without having to reinvent the wheel. So you can explore existing knowledge objects in here. So some of them have nice documentation and even videos to show how to use them. There are knowledge objects that explain how to, for example, define COVID positive patients or compute some severity scores. So feel free to explore it. You can also look at the author, just select knowledge objects that were created by a specific person. And that's another way to browse your knowledge objects. There is a comment section. So if you want to iterate on the specific logic with the creator or the author, you can use this comment section. So that was the knowledge store. I went a little bit quickly on it, but there are some resources in here. If you open the knowledge store and you click on, and you click on resources, you have a knowledge store guide that gives you all the available functionality and how to use the knowledge object with some screenshots to guide you along the way. So the last thing on this presentation that I wanted to mention without spending too much time on it is another tool called the Phenotype Explorer, also available within the Discover tab of the homepage. So if you go to the Discover tab, the Phenotype Explorer is a dashboard that gives you some high-level statistics about the existing cohorts within the Enclave. So that could be a good starting point if you're not sure what data is available within the Enclave and want to have some basic statistics. And it could be a good starting point for your analysis. So first exploring the data available, and then using the specific cohorts within your contour or code workbook analysis. So as you can see here, this is the entire cohort within the template. It gives you some basic statistics. You have a breakdown by race, sex, and ethnicity. You have a comorbidity distribution of the cohorts, and then you can just pick some specific labs or vitals and look at their trajectory. And you can do the same thing for medications. So that's for the entire cohort, but you can also explore the existing phenotypes. And let's say, for example, I want to look at the diabetes phenotype. This gives me information about the type 2 diabetes phenotype, and I can explore it here and compare it with the entire cohort. So you have some numbers here, the COVID positive percentage versus what we have in the entire cohort. And then, so that's on the Phenotype Explorer. And then lastly, let me go back to point to some existing resources, because I know this was a lot of information and we went a little bit quickly on it. This is some available. So again, we've talked about the training portal. Let me actually open it to show you how it looks like. So that's in the training section of the homepage. The training portal is a collection of trainings and tutorials specific to the Enclave. So not necessarily just about Contour and Code Workbook, but you can see things like Enclave organization, how to navigate intro to OMOP, a crash course on OMOP vocabularies if you want to get used to and get more familiar with the data model. There are tutorials about using Atlas to, for example, import concepts or phenotypes. And if you click on each one of these modules, this gives you some metadata and information about the topics covered, the estimated time, and then the resource. So it could be a YouTube video. We have also some walkthrough tutorials. So pretty useful to get started. And then other training resources are, like I mentioned earlier, the Academy. So the Academy is some very short and self-guided tutorials that walks you through the tools within the Enclave, like reports, like Contour, like the spreadsheet. So there's a tutorial on reports. There's one on Code Workbook. So if I click on it, it's basically a self-guided tutorial. So you can click on Start Tutorial and then follow along the instructions. So if you click on Projects and File, it's going to check the mark and you can follow along. That's also another quick way to get up to speed without looking at the more in-depth documentation. And the more in-depth documentation is, in case you still don't find your answer, in the quick tutorials, there is this docs, which is more information about the available tools such as Code Workbook and Contour. Or if you get more advanced and want to use other ETL data transformation tools, you have all the documentation in it within this documentation resource. So that's on the trainings. We've mentioned the tutorials, we've mentioned the platform documentation. We've also mentioned filing issues within the platform. So again, from this button in here, you can file an issue and ask a question or report a bug or a question about the data. We have office hours every Tuesdays and Wednesdays, and sorry, every Tuesdays and Thursdays. And then one of the good ways to help with your research is to collaborate with existing domain teams. So you can go to the website, join their Slack or their Google Drive, and then join their meetings. And that's an excellent way to ask questions on how to get started with your research. And maybe some of the questions you're asking have already been answered by the domain team. So it's a good way to collaborate within the community. And here are just some of the resources. If you want to get familiar with the Odyssey tools and the OMOP data model, we'll include this in the training portal, so you'll have access to them. Yeah, so with that, I'm going to stop the presentation and see if you guys have any questions or